So, um, yesterday we talked about, in the day before, how to write a vector in component form. You guys remember what that means? You just describe how far it goes to the right and left, or left and down, or whatever. To the right and up. So it's right 2, up 3. So if I call this vector v or whatever, it would just be 2, 3. Okay, but on today's we're talking about the vector, like going over time. Like maybe this is how far you drove in 1 hour. So how far would you get in 2 hours? So that would, the picture would look like this, but how could we represent it? These are called vector equations. So you just start with the starting point. So in this case, it would be at 2, 1. And then basically you add on how far is it moving for each unit of time. So in this case, it's moving right 2 and up 3, just kind of like that thing from yesterday. But we put a little variable in there, t, for time. So after 1 hour, where will the, whatever is traveling along this line, where would it be? It would be at 2, 1 plus 2, 3, which is 4, 4, right here, after 1 hour, whatever it is. After 2 hours, it's going to be way up there. So if t is 2, 2 times 2, 3, plus 2, 1, that'll give you this point right here. Or you could say, where's it going to be after an hour and a half? Right there. Or where's it going to be in half an hour? Right there. Right, so you just plug in the time right there and that gives you the location. The other way we are going to write it, and it's pretty much the same, almost the same thing, it's called parametric form. And that's when you specifically say the x value is going to equal, basically the x value is going to equal 2 plus 2t. Because that's where the x values come from. And then you do comma, y equals, and then you do 1 plus 3t. Do you guys see where I got those numbers from? Okay. So it's pretty close to this. It's just a different way of expressing it. This one's probably more efficient. Okay, that's kind of pretty much the idea. And you could also do a negative time here, like go backwards in time an hour. Put you backwards. Alright, I didn't write the assignment down, did I? I forgot to look it up. 435. Yeah, we'll see how it goes. Okay, so on number 1, it's starting, the line is going through 1, 5 with the direction vector of 2, negative 1. So we're using vectors to describe locations on lines, basically is what's happening. And kind of using time as a variable. So 1, 5, we could use it as our starting point. So we're just going to put x, y equals 5 plus t, and then the direction of the vector is to -1. So that's just basically they're telling us what goes over here. Okay, that's the vector equation. What's the parametric equations? X equals 1 plus 2t. Y equals 5 minus 1t or 5 minus t. Okay, so number 3 looks a little bit more like the example I put on the board. You're going from 1, 0 to 3, -4. That will be like our motion. So 1, 0, we can use that as our starting point. Actually, you could use either one as a starting point, but let's use the first one. 1, 0 plus t. Okay, now over here, we haven't really figured out yet how this vector is moving. If you're going from 1, 0 to 3, -4, do a little sketch. It's going to be along this line, right? So we need this, like basically the component form of this vector to describe which direction it's moving. So if you're going from 1, 0 to 3, -4, what's happening to the x values? 1 to 3, it's going up 2. What's happening to the y values? 0 to -4, it's going down 4. So that vector is 2, -4. So the parametric equation okay, you could say 0 minus 4t. That would just be the same thing as -4t. Number 5, same thing. I'm going to do it without drawing a picture this time. -2, 3, and 5, 1. So I'm going to use -2, 3 as my starting point. And then, how far is it moving in the x direction from -2 to 5? If you're not sure, you can just do 5 minus -2. But that would be 7. How far is it moving from 3 to -1? That would be down 2. So the parametric equations. Okay, the horizontal line through pi e, that's a weird question. Well, what could we use as a starting point? Pi e will do just fine. Okay, now if it's a horizontal line, I'll look at the graph, I guess. Do you guys remember what e was about worth? Pi is about 3.14, e is about 2.72. So it'd be like right there, kind of a random spot. they're both irrational, like weird numbers. That would be what the line looks like. So how could we describe the direction vector? Well, it's just moving right. It doesn't really matter how far right you use for it. You could say it's like going that far or that far. So I'm just going to put, to move to the right, I just need a number right there, and it's not moving up or down any, so I just put 1, 0. I could have put 2, 0 or 3, 0 or negative 1, 0 or whatever. But that 1, 0 would move it to the right. All right, so the x value is pi plus t. The y value is e. E plus 0t would just be e. So 8 will look pretty similar to that one, but it's a vertical line instead of horizontal. Graph. Darn. Only these two want graphs, but that's okay. We're going to do it anyway. I think it's worth our time. Let's see, you got a half sheet. Get one cadence. All right. Graph the point's position at times t equals 0, 1, 2, 3, negative 1. So many. All right. So, I'll go ahead and write it down. 1, 4 plus t, 3, negative 2. Okay, where is this going to be when t is 0? Okay, when t is 0, this will be nothing, right? So the movement vector is not being used. So it's at the starting point, 1, 4. So that would be t equals 0. I wonder if we should label these. Did they label it? Yeah, of course they did. All right, that's fine. T equals 0. Okay, when t equals 1, what's going to happen? Well, we're going to move right 3 and down 2. from the starting point. So it just goes right 3 down 2. That's t equals 1. What's going to happen on t equals 2? Well, you're going to move another vector's length of 3, negative 2. So you could say it's 6, negative 4 from this point, but really it's just going to be another 3, negative 2 from the last point, right? It's 6, negative 4 from the start, but it's only 3, negative 2 from the last t. And every t, whether t is an hour or a minute or whatever it is, it's going to move 3, negative 2. How far did it tell us to go? To 3 and to negative 3. I don't know if I'll fit negative 3 on here. So what's going to happen when we put t as negative 1? Well, it's going to move, instead of right 3 down 2, it's going to move left 3 up 2. It's going to go back in time. So left 3 up 2 would be right here. That's at t equals negative 1. Not going to fit it on my graph. Left 3 up 2, that's going to be at t equals negative 2. And then one more up there for t equals negative 3. Okay, B, find the velocity and speed of the moving point. So our graph here kind of represents where's the point over time, like after 1, after 2, after 3. Gives you a little, it moves continuously, but this gives you just a little snapshot of where it is at certain times. Let's see. So for the velocity, what they mean is basically it's going to be the direction vector. Okay. So for the b value, we're just going to put 3, negative 2. And what they mean for speed is how fast is it going in 1 t. So in other words, like how long is it from here to here? And how do we find the length of that? Right, Pythagorean theorem. 2 squared plus 3 squared equals this squared. So 4 plus 9 is 13, so this would be square root of 13 long. So it's the magnitude basically is what they mean by the speed.
I think the speed was a part of answer B.
Was it B and then C?
Find velocity and speed.
Oh yeah, you're right. It's the same question, my bad. Okay, just put a comma there then. And then it says find the parametric equation, so it's kind of easy one, but so it's x equals 1 plus 3t, you know, that stuff we were doing earlier. Y equals 4 minus 2t. Number 11. In exercise, find vector and parametric equations of the moving object described. Okay, so kind of the same as like number one, basically. The velocity is 3, -1. That's the direction vector, basically. The position at time t equals 0 is 2, 3. That's telling us we're starting at 2, 3. So that's the starting point. So, and then the velocity is the direction it's going to head, 3, -1. It said parametric too, didn't it? Okay, 13, a line has vector equation, blah, blah, blah. Give a pair of parametric equations and a Cartesian equation of the line. That's different. Okay, so the parametric equation is what we've been doing a lot of already. So it's just x equals 3 plus 2t. And y, I lost my place. Y equals 2 plus 14. Any idea how we can make an equation, like a linear equation? That, what they mean by Cartesian is like a normal linear equation that we're kind of used to, instead of like a vector thing. So remember, usually we write linear equations like y equals 2x plus b, or something like this, y equals mx plus b. So let me write the original down, then we'll talk about it. 3, 2 plus t, 2, 4. So when we use y equals mx plus b, we need the slope and the b value, and then that's the equation. How could we find the slope here of this thing? So it's going from 3, 2 to 2, 4. How do we find the slope of this line? Oops, sorry. It's going from 3, 2, and then it's going up 2 and over 4. 1, 2, 3. So it looks like that. It's going, starting at 3, 2, moving right 2 up 4. What's the slope of this line? Well, basically it's going up 4 and over 2, right? Rise over run. It's going up 4 over 2. So the slope is 4 over 2, or 2. But how do we find the b value, the y-intercept? Well, you could maybe like count down and see where it is, but if you just plug in a point that's on the line for x and y, you can use that information to find out what b has to be. So 3, 2 is a point on the line. So if we plug in 3 and 2 for x and y, that should give us the information that we need to figure out what b is. Is -4, so that would be an equation of the line. Yeah, we're kinda run out of time. Let's just go to 14, I guess.